Real or virtual? Inverted or upright? Smaller or enlarged? How are images formed in plane and spherical mirrors? Hello, Sci-Files! I am Ma'am Laorny La Chica, your science teacher for today. In this episode of Agham Alam Hub, we are going to explain image formation as an application of reflection in plane and spherical mirrors. We will also describe the characteristics of images formed through plane and spherical mirrors with the use of ray diagrams. Finally, we are going to appreciate the important applications of plane and spherical mirrors in real-life situations. In the next few minutes, we will explore science for another moment. Remember that objects can be seen by the light they emit, or more often by the light they reflect, which forms images. Reflected light obeys the law of reflection, which states that the angle of reflection is equal to the angle of incidence. A mirror is a polished or smooth surface, such as glass, that forms images by reflection. Its invention is credited to the German chemist Justus von Liebig in 1835, in which he developed a process for applying a thin layer of metallic silver to one side of a panel of clear glass. This technique was soon adopted and improved upon, allowing for the mass production of mirrors. Mirrors can be plane or spherical. A plane mirror is simply a mirror with a flat surface. Spherical mirrors are either concave or converging and convex or diverging, depending on which side of the spherical surface is reflective. If the inside surface is reflective, the mirror is concave. If the outside is reflective, it is a convex mirror. How are images formed in a plane mirror? To figure out where the image of an object is located, a ray diagram can be used. In a ray diagram, rays of light are drawn from the object to the mirror, along with the rays that reflect off the mirror. The image will be formed where the reflected rays intersect. In a plane mirror, random rays can be drawn from the object to the mirror and follow the reflected rays. However, there are three rays in particular that are very easy to draw. The first ray is the parallel ray. It is drawn from the tip of the object parallel to the principal axis. It is then reflected off the mirror and can be extended back on the other side. The second ray is the chip ray. This is drawn from the tip of the object to the mirror through the center of curvature. This ray will hit the mirror at a 90 degrees angle, reflecting back the way it came. The chip and parallel rays meet at the tip of the image. The third ray, the focal ray, is a mirror image of the parallel ray. The focal ray is drawn from the tip of the object through or towards the focal point, reflecting off the mirror parallel to the principal axis. For plane mirrors, the third ray is the same as the first ray. All three rays should meet at the same point. Based from the ray diagram, an image produced by plane mirror is virtual, since the image is formed behind the mirror. In terms of its orientation, it is upright. The image form has the same distance from the mirror as the object being reflected. For its magnification, the image has the same size as the object. This time, let us look at how images are formed in spherical mirrors. A spherical mirror is simply a piece cut out of a reflective sphere. It has a center of curvature, which corresponds to the center of the sphere it was cut from. A radius of curvature, which corresponds to the radius of the sphere, and a focal point, the point where parallel light rays are focused to, which is located half the distance from the mirror to the center of the curvature. The focal length, f, is therefore f is equal to r over 2. To determine where the image is formed using a concave mirror, we will again draw a ray diagram. The first ray is parallel ray drawn from the tip of the object parallel to the principal axis. It is then reflected off the mirror and passes through the focal point. The second ray is the chip ray, which is drawn from the tip of the object to the mirror through the center of the curvature. This ray will hit the mirror at a 90 degrees angle, reflecting back the way it came. The chip and the parallel rays meet at the tip of the image. The third ray, the focal ray, is a mirror image of the parallel ray. The focal ray is drawn from the tip of the object through the focal point, reflecting off the mirror parallel to the principal axis. The image is formed where the three rays intersect. Take note that the image formed by a concave mirror will vary depending on the location of the object. Situation number 1. An object beyond center of curvature will always have a real, inverted image that is smaller than the object and located between the center of the curvature and the focal point. Situation number 2. An object located at the center of curvature will always have a real, inverted image that is the same size of the object and located at the center of curvature as well. Situation number 3. An object located between center of curvature and focal point will always have a real, inverted image that is larger than the object and located beyond the center of curvature. Situation number 4. An object located at the focal point will not produce any image. Light rays from the same point on the object will reflect off the mirror and neither converge nor diverge. After reflecting, the light rays are traveling parallel to each other and do not result in the formation of an image. Situation number 5. An object located in front of the focal point will always have a virtual, upright image that is larger than the object and located on the opposite side of the mirror. This table can be used to easily remember the characteristics of images formed by a concave mirror in different situations. Let us now discuss how images are formed by convex mirrors. To determine where the image is formed using a convex mirror, we will again draw a ray diagram. The first ray is parallel ray drawn from the tip of the object parallel to the principal axis. It is then reflected off the mirror and passes through the focal point by extending back the ray. The second ray, the focal ray, is a mirror image of the parallel ray. The focal ray is drawn from the tip of the object through the focal point, reflecting off the mirror parallel to the principal axis. The image is formed where the two rays intersect. Take note that the image formed by a convex mirror will always be virtual, upright, smaller than the object, and located behind the convex mirror. Unlike concave mirrors, convex mirrors always produce images that share these characteristics. The location of the object does not affect the characteristics of the image. As such, the characteristics of the images formed by convex mirrors are easily predicted. We know that the effective use of mirrors is to see reflections of objects. We use mirrors almost in every situation where there is a need to look at ourselves or for what is around us. Plain mirrors are used as looking glass. It is also used as reflecting plates in microscopes. They are also used in constructing periscopes, which are used for signaling in submarines. Plain mirrors are also used to make kaleidoscopes. These are toys which produce beautiful patterns. Concave mirrors are used in torches, searchlight, and vehicles' headlights to get powerful parallel beams of light. It is also used as shaving mirrors to see larger images of the face. Concave mirrors are also used by dentists to see large images of the teeth. Meanwhile, large concave mirrors are used to concentrate sunlight to produce heat in solar furnaces. Convex mirrors are commonly used as rear view mirrors in vehicles because they always give an erect image and have a wider field of view as they are curved outwards. Big convex mirrors are used as shop security mirrors. The shop owner can keep an eye on the customers to look for thieves and shoplifters among them. In this episode of Agham Alam Hub, we explained how images are formed as an application of reflection in plane and spherical mirrors. Through the use of ray diagrams, we determined the characteristics of image formed through the plane and spherical mirrors. We found out that plane mirrors always give a virtual and upright image that has the same size as the object. The image has the same distance from the mirror as the object being reflected. Concave mirrors can form both real and virtual images, or no image at all, depending on the location of the object. When the concave mirror is placed very close to the object, a virtual and enlarged image is obtained. If distance between the object and the mirror is increased, the size of the image reduces, and the real image are formed. On the other hand, images formed through convex mirrors are not affected by the location of the object. Instead, it will always give a virtual and upright image that is smaller than the object and is located behind the convex mirror. Finally, we identified different applications of plane and spherical mirrors in real life. Plane mirrors are used in periscopes, kaleidoscopes, and as reflecting plates in microscopes. Concave mirrors in torches, searchlights, shaving mirrors, dental mirrors, as well as in solar furnaces. Convex mirrors are used as rear view mirrors in vehicles and shop security mirrors. Mirrors allow us to see reflection of objects. With the vast applications of mirrors in our daily lives, it paved the way to various contributions that benefited mankind. That's all for today's iPulse. Don't forget to like, share, subscribe, and turn on the notification bell. See you again next week for another moment. Only here in Agham Alamhab, Palajan SciTech Portal. Bye!